Hello everyone, my name is Inki Sul. I'm a PhD student in Jindal School of Management at University of Texas at Dallas. I would first like to thank the organizers of 2020 Revenue Management and Pricing Section live paper series for giving me this great opportunity to present our work, which is about the empirical investigation of customer regret under markdown pricing and its implications to retailing. This is joint work with my advisors in UT Dallas, Professor Sozal Bazar and Serdar Shimshek. Let's go ahead and start. So in this project, we empirically characterize how anticipated regret affects purchasing behaviors of customers that confronts markdown pricing structure using structural estimation method from field data. Let me first start by defining what regret means. So from economics, regret is a negative emotion that arises when an individual engages in counterfactual thinking of the path not chosen and compares the outcome of one's choice to other foregone alternatives. In a retail context, regret is a negative emotion that customers feel about their purchase instances given the pricing and availability structure of a markdown product. So let me explain the two types of regret that we model that stems from markdown pricing with a motivating example. So everybody's staying home for now, but you sometimes want to look nice and you're interested in purchasing this $300 blazer. You know that there's going to be a markdown, but you don't want to risk not finding it in the markdown season, so you decide to purchase it now during the regular season. Now you visit the store a month later and see that the exact same jacket is available at a markdown price of $180. At this point, you might be thinking, hey, I should have waited until markdown and pay less, right? This is what we call a high price regret. Now consider this alternative scenario that you waited in anticipation of a markdown, but discovered that the size and color you wanted was unavailable during the markdown season. If this happens, you might be thinking, hey, I should have purchased that regular period when the blazer was there, right? This is what we call a stock out regret. One important thing to note here is that we're not really interested in the realization of these regrets, but rather interested in the anticipation of these regretful emotions. Say that the line here represents the selling season of a product, then both of the types of regret are realized in the markdown season. However, we are interested in how customers feel in anticipation of these regrets and how purchase decisions are affected. This enters the customer decision-making process ex ante, right? So hence, we are interested in the effect of anticipating these two types of regrets ex ante before decision-making on the purchasing decision of the customer, whether or not the customer purchased the product, and if so, during which of the following seasons. So with this in mind, we can formally introduce our research questions. First, does anticipated regret affect customers' purchasing decisions? And if so, can we quantify it? Second, given that we can estimate it, how does anticipated regret parameters differ across different categories? And finally, what implications do they have on the retailer's markdown pricing strategy? And our contribution is as follows. We first develop a novel and tractable method to estimate the demand parameters and anticipated regret parameters jointly with structural estimation. We then provide interesting implications of different levels of anticipated regret, and we also quantify the value of considering anticipated regret in the pricing optimization. Briefly going over the literature, we contribute to the revenue management and pricing literature by bringing this important behavioral regularity of regret into pricing optimization structure that enhances markdown pricing. We also find that the literature on anticipated regret is mainly analytical and experimental, so we filled the gap in the literature by providing empirical evidence of regret from actual field data. Methodologically, we contribute to the growing stream of structural estimation in OM to identify our regret parameters and provide data-driven insights for retailers. So we start by discussing our data. Since this is a data-driven project, we obtain data from our partner retailer, which is regularly featured in Fortune 500 list of companies. Although our retailer have both online and brick-and-mortar operations, we take the data from their online operations only for 3 years of time horizon. And the clean data looks as follows. For individual product with their category information, we have the sales transaction information at the customer level, And we also have their web clickstream data of customers, which includes product pages visited and price and availability information at the time of each customer visit. So we focus on 12 different categories, 5 from menswear, 6 from women's wear, and 1 from children's wear. For 3 of the categories, pants, sweaters, and outerwear, they both have women's wear and menswear counterparts, which allows us to make interesting comparisons between regret characteristics of menswear and women's wear. And we ended up with 514 products in our sample data set, with products that have only 1 regular season and 1 markdown season. Now let me walk you through our customer purchase decision model. We consider a single product that customer considers purchasing. Customers know the price discounted in the markdown season. Think of this as a marketing strategy that a retailer engages in, such as biannual discount. We can actually verify from our data that discount rates do not vary too much, and we assume that customers have advanced knowledge to this. And they also predict the availability of the product during the markdown season from past experience with their retailers or by observing availability of similar products. And based on these information, customers decide whether and when to buy the product. And customers purchase the product when their heterogeneous and privately known reservation prices is higher than price offer from the retailer, and retailer knows the distribution of this only. And customers are homogeneous at the product level in their regret characteristics. So in this setting, we represent the decision of the customer in the form of a decision tree. If the customer arrives in the regular period, they can either purchase or wait for the markdown season or not purchase at all. Consider the scenario of customer purchasing in the regular season. Then, if the product is available in the markdown season, then high price regret is going to be incurred. Utility in this case is modeled by 2 components. First, the left term is the economic utility, or consumer surplus. V represents the customer's reservation price, and PR, the regular season price. And the right term here is the behavioral utility. Following the standard regret modeling literature, the effect of high price regret is modeled as a mental discount that is proportional to the foregone alternative, the money that the customer could have saved when purchasing at the markdown season, and the intensity of this regret is represented by this intensity alpha. In the following 2 terms, there is no behavioral utility because there's nothing to regret. And now, the stockout regret materializes when the product is stocked out in the markdown season, when the customer decides to wait for the markdown season. There is no economic utility in this case, and the magnitude of this regret is represented by parameter beta here, and this is proportional to the surplus she could have achieved if purchased in the regular season. However, remember that we are not interested in the realized utility, but rather in the expected utility ex ante to decision making. So using the customer's expectation of stockout during the markdown season, which is here denoted by probability S, we can uncondition these utilities and compute the expected utility of each of these options. So customer makes her purchase decision by comparing the expected values from buying in either period or not buying at all. So by comparing these utilities, we can derive the demand characterization results as a function of the customer reservation price V. We find that there exists this threshold value V1 that is an indifference reservation price between regular and markdown purchase. This is a function of all the parameters in the model, but regret affects the threshold reservation price and thus customers' purchase decision only through the relative magnitude of these 2 types of regrets. This is actually good news for us researchers and retailers because if you only know the relative magnitude of these 2 types of regrets, which we call regret ratio here, that is enough to capture the effect of regret on customer decision. So from now on, we focus on estimating this regret ratio eta. Now from here, we discuss our estimation strategy. We use the maximum likelihood estimation, and for our reservation price distribution, we select Weibull distribution, which is widely used in the literature and is also flexible enough for our setting. We also did our robustness checks with alternative distributions, such as log normal and log logistics, and find that the results are pretty much the same. Then we estimate these parameters from the likelihood function. Eta here, which is the regret ratio, and lambda and k are the parameters of reservation price distribution. So from this likelihood representation, we count the number of markdown sales and regular sales and no purchases from empirical data, call them N0 and M and NR respectively, and multiply the probabilities of each demand classes to the power of respective number of customers observed from data. However, when maximizing the likelihood as is, we run into the problem of continuum of optima, which means that there are multiple optimum triplet of regret and reservation price parameters that maximizes the likelihood function. So how do we get around this problem? We reduce the dimensionality of the problem by introducing a constraint to our maximization problem that is coming from an identification assumption that looks as follows. We say that the retailer knows the true parameters of customer reservation price distribution using more historical data amassed or other sophisticated tools, and use that information to optimize their regular price without the notion of regret, which is what they're doing right now. This means that we take the observed regular price from data as a result of this retailer's optimization. So this assumption enters our likelihood maximization problem as a constraint, and now we have a constrained maximization problem to solve. And we test our methodology on simulated data first to show our estimation strategy works, although I'm skipping the details, but I can assure you that our methodology works well. So now we present our results of estimating the regret ratios from actual field data. We start with the product level analysis. The figure displays the regret ratio estimates. The blue points here represents the point estimates of regret ratio of each product, and the bar represents the 95% confidence interval obtained from non-parametric bootstrap method. One thing to note here is that if eta equals 1, represented by this red dotted line, it may mean that either both types of regret do not exist, which means alpha and beta are 0, or the intensity of both types of regrets are equal to each other, so that they cancel out from the customer behavioral standpoint. Now, for 89% of the products, we find that anticipated regret affects customer behavior, meaning that eta is significantly different from 1 for those products. This serves as an empirical evidence that the effect of regret on customer behavior is there. Also, products below the red dotted line means that magnitude of stockout regret is higher than high price regret, and vice versa. And our estimation shows that stockout regret is more salient than high price regret for over 90% of the products in our data set. Now, as the next step, we aggregate the estimated regret ratios by category and present this result in this table with their means and standard deviations. So a couple of findings. First, on average, women's wear have lower regret ratios from 3 categories that have both male and female counterparts. This result can come from 2 reasons. Either it can come from menswear having a higher high price regret, or women's wear having a relatively higher stockout regret. We later confirmed that when we disentangle the regret ratios into separate regret components, applied a few slides later, that the reason is because on women's wear, customers have a higher stockout regret. Also, we see high fluctuation in the standard deviations of regret ratios in the categories too. So due to this heterogeneity observed across and within categories, we conclude that one-size-fits-all pricing adjustment when implementing anticipated regret is not advisable. Rather, it should be at the product-specific level. We also provide product-level regression analysis with category fixed effects to understand the correlation of regret ratio with customer-level characteristics, which we can also find from our data set. And we see that the salience of stockout regret over high price regret is even more prevalent for products with more high spending customers and more frequent website visiting customer base. Now, we quantified the effect of considering anticipated regret in the retailer's pricing optimization with a counterfactual analysis. To do that, We first computed the optimal regular price for a given discount rate and target fill rate with estimated regret information and simulated the customer's choice under this new pricing structure. We then compared the difference of simulated revenue per customer in two different scenarios, one before considering the regret and after considering the regret characteristics. And overall, we find the average percentage increase in revenue of 1.64% with a maximum of over 11%. The table represents the average revenue increase per customer by category. And the highest average revenue increases comes from these women's wear categories, which we can provide to the retailers to first advise implementing these categories and maximize the revenue increase. Lastly, we provide one way to disentangle the regret ratio. To do this, we fix one of the regret parameters, high price regret, by obtaining a proxy from exogenous regression performed at the category level. So for each category, we take the product's regular season demand over all demand as the dependent variable, which is a proxy for regular purchase utility. When you look at this regression resembles the regular season purchase utility formulation, as foregone discount representing the amount of discount saved when purchasing in the markdown season. So this alpha hat becomes the proxy for high price regret of category J. Note that the magnitude may not be comparable, so we normalize the magnitude by computing this for all categories and dividing them with the maximum proxy obtained. And we can also compute the proxy for stockout regret by backtracking from the category average of estimated betas. So here I present the high price and stockout regret indices ranging from 0 to 1 in increasing order of magnitude. When we look at the high price regret index for pants and sweaters only, the high price regrets are comparable for men's and women's wear, but the salience of stockout regret is much more prevalent for women's wear, and this is what drives the lower regret ratio for women's wear, as we've seen earlier. So to conclude, we propose a joint estimation strategy to estimate regret characteristics and reservation price distribution so that we account for customers' both strategic and emotional reactions to markdown pricing. And using the estimates from a dataset from a major luxury fashion retailer, we were able to shed light on the existence of regret in customer purchasing decisions. And stockout regret dominates high price regret for most of the products. And women's wear has higher stockout regret than men's wear counterparts. And lastly, we quantified the value of incorporating anticipated regret in markdown pricing optimization, which ranges over 11% for some products. This is a considerable boost in revenue achievable with virtually no cost involved, just better pricing. So thank you very much for your attention during the presentation, and don't hesitate to reach out to us for any kind of comments and questions.